Welcome. I'm going to go through the problem step by step. So here we go. Let's see. Okay, so remember to make a chart because it's critical to keep your X and Y separate. If not, if you can, it's a bloodbath. Okay, now what's happening is he's launching a lacrosse ball at an angle of 35 degrees and a speed of 25 meters per second. Now, since that's in the diagonal, it can't go in the chart, okay? What we need to do is split this into its components, a Vx, which never changes, and a Viy that constantly changes, okay? Let's see, move slightly out of the way. There we go. All right, and then it's going to follow a parabolic trajectory, okay? All right, now, we need to find those formulas. And if you go on the front of your reference tables to these vector formulas that we used at the beginning of the year, where A stands for any vector quantity, in this case, initial velocity, and these are the components, and then theta is the angle. So, Vx, the one that never changes, is equal to Vi cosine of theta, and Viy, which does changes, which is why we need to distinguish that its initial velocity, is equal to Vi sine of theta. So let's go ahead and plug and chug. So that's 25 meters per second times the cosine of 35 degrees. And Viy is equal to 25 meters per second times the sine of 35 degrees. All right. Make sure you're in degrees and not radians. And the Vx comes out to be 20.48 meters per second. And the Viy comes out to be 14.34 meters per second. These are what can actually go into the chart. All right, so Vx equals 20.48. And Viy equals 14.34. Now, everything else is hidden information. We know that because we're near the surface of the Earth, the acceleration due to gravity is 9.81 meters per second squared. And because I'm going to say down is my negative direction, I'm going to make that negative. And that goes on the Y side because gravity doesn't act in the X. And the other thing is that at the top, the Vy equals 0. And because I'm in charge of what's initial and what's final, I am going to say this is the Vfy. These two hidden information are always true in this class. If you shoot something down at an angle or up at an angle from a from a height, then the Vy might not be 0 at the top because you're shooting it down, right? But that's beyond the scope of this course. All right, now, when in doubt, find time, and that's what they reminded you here, because time is the same on the X and the Y. So what we need to do is find which side we have enough information to find time on, right? And then we're going to pick a formula from the reference tables, right? Okay, so let's see. Oh my goodness, it's right here. Okay, so I have Vi, A, Vf, and I want T, so I'm going to use this formula here. All right, Vf equals Vi plus AT. And again, you either need to be really careful about keeping X and Y separate, or you need to use subscripts. Okay, let's go ahead and substitute in. 0 equals, the initial velocity is 14.34. Notice I am not putting this diagonal one in. Diagonals don't go in any formulas. Plus a negative 9.81 times T. All right. Now I can do my algebra. And if I do that, I find that T equals, let's see. I'm going to do a couple steps here. 14.34 divided by 9.81. And I get 1.46. This is the time up to the top where the velocity is 0. So to get total time, I need to double this. And so total time equals 2.92 seconds. Okay. So one of the things that makes these problems harder than the horizontal problems are because you have to make sure that you keep track of time up, time down, total time, that kind of thing. All right. Now range is total range, so I need to use total time here. All right. Now that we know that the time is 2.92 seconds, we can now pick a formula to use on the x side, and that is always the same. All right. It's v equals d over t, which is what we use on the x side. And again, you got to be careful to use subscripts if you're not being super careful about keeping your x and your y separate. All right. I'm going to rearrange this and get that dx equals vxt. So dx equals, the vx was 20.48. Again, notice I'm not putting the 25 in there. That's the diagonal information. Diagonals don't go in either horizontal or vertical. And then total time. All right, and when I do that, I get that the total distance equals 59.8 meters. If you got half of this number, it's because you forgot to double your time. Okay, let's move on to the next question. Okay, so now we have Joe at the terrain park. Okay. And he is also jumping. So he's jumping up at an angle. All right, we're going to split that into horizontal and vertical components. Excuse me while I'm awkward. Okay. And then it follows a parabolic trajectory. All right, so once again, I need to find the horizontal and vertical components. So Vx equals Vi cosine theta. And again, that's the one that never changes because horizontal motion doesn't change in free fall. And Viy is Vi sine theta. All right, so I'm going to put these numbers in. Let's see. 15 meters per second times the cosine of 35 degrees is Vx. And Viy is going to be 15 meters per second times the sine of 35 degrees. And if I do the math here, I get that the Vx is 12.29 seconds. And that the Viy is 8.6 meters per second. Okay, now we can make our chart. Boop. Okay, let's move this over so it's not in my picture. That couldn't help. There we go. Okay, so let's see. Vx equals 12.29 meters per second. Viy equals 8.6 meters per second. Same hidden information as before. The Vfy equals 0 at the top. And acceleration, since we're near the Earth, is negative 9.81 meters per second squared. And again, I'm going to make down my negative direction. All right. Let's see. How much time? Again, when in doubt, you're going to find time, but they're reminding you to find time. So same formula we used before. Vf equals Vi plus At. Again, be careful to use subscripts unless you're being super careful about keeping x and y separate. All right, so 0 equals 8.6. Again, notice I'm not putting the 15 in here. All right, plus a negative 9.81, because down is the negative direction, times t. And when I do the algebra on that, I get that time equals 4.2 seconds. That does not make sense. I'm going to pause and find a mistake here. Oh no, I got it. Alright, I think time is 8.6 divided by 9.81. And I get that time is 0.87 seconds. That's half times. That's the time up to the top where the VF was 0. So now I have to double that. So that's just the time to his maximum height. So actually that's what they were looking for. Okay. But if you wanted to know, total time would be 0.87 seconds times 2. But we don't actually need that. All right. How high does he jump? So he's at his maximum height at the middle here where the velocity is 0. So we have to use a half time here. Okay. So now we know that half time is 0.87 seconds. And we're now looking for the height, which is dy. Okay. So again, we need to pick a formula from our reference tables that has all these things in it and nothing else. In fact, we have a choice here. And I am going to use, I think, d equals VIT plus 1/2 AT squared because that's already solved. But you actually have a choice to which formula to use here. So one way you could do it is do d equals VIT plus 1/2 AT squared. You could also use VF squared equals VI squared plus 2AD. All right, again, either be super careful about keeping x and y separate or use subscripts. All right, we're looking for dy. So dy equals VIY 8.6. Again, notice I am not putting the 15 in here because that's diagonal. Times a half time, 0.87 seconds. Plus 1/2 times negative 9.81 times 0.87 seconds squared. Okay. When I do the algebra on that, I get that dy equals 240 meters. Now, a couple of things to watch out for. If by mistake you used total time here, you'd be back on the ground and you'd have a dy of 0. Okay, except because of rounding, it's never 0. It's always some like slightly lower number, or slightly higher. It's like because of rounding, it's like a couple of centimeters. So note to self, if you're trying to find out how high something jumps, right, and it's not a flea, okay, and you get a super tiny answer, you might have used total time, and you might have actually found the distance it's at when it's back on the ground. All right. Good luck.